So in this particular example, we will see how to create a class and then use the this pointer and use the this pointer to modify a get function and also display the address. Okay, so we'll create a simple class student. So it has two member variables. It has a constructor, default constructor. It initializes the member variables. Right, it has a set function. So void right, and here what we can do is we can say create a get function. So we can write string, so just get name, and then we can take a look at a function that displays the value of the pointer. So we can have a void so display the address of the this pointer. So we can write cout right. So we know that this pointer holds the address of the object that made the function call. So you can only use this within a function to which function call was made by an object. Okay. So here we have the main function. Right, so here what we can do is we can create an object of the class student. So we can call student Bob. Right, and we can say Bob dot set name Robert. Right, and so far this is stuff that we've already seen. So if you run this program, you want to see the name of so you can say display the name. The name is right, so we have two get functions here. So this is kind of a get function even though this is a void. We'll see out in here. It will display basically whatever is in this. So this will be the hexadecimal format. The address of the object which made the call to this function, display address function. So we already know that when a function makes a call to an instance function, it always sends its address to the implicit parameter, which we don't see here, but it's there, right? So which would be the pointer to the class, or it would be student space star ptr, right? Something like that, a pointer to the class, object of the class. So if you run this, right? So here's the output of the program. As you can see, the get name is showing us Robert. And the address of the object is, this is the hexadecimal notation of the memory location of the object Bob. So the this pointer holds the address of the object that made the call to a certain function, and it can be displayed from within that function only, okay, not from outside the function. So here in the display address, we are using this. This means the address of the object that made the call to the function display address. Now here we discussed that it's entirely possible to mess with get functions, and what we can do is we can use this pointer within the function to modify the value of the name member variable. So we're going to start this. Just type some gibberish here. So what we're doing here is we are, this is a get function. So get functions are not supposed to modify the values. These are accessors, not mutators. So a get function's only job is to display the information, but using this pointer, it is possible to modify the value of the member variables of the object that made the call. So we are within the class, so we can use dot name, because within the class you have access to the member variables. Now if we run this function one more time, let's see what happens. So name is some gibberish and the address is the same address as before. So what happened here was that using this pointer, so you can use this pointer notation, or if you like simpler one, which I prefer myself honestly, the SPO. This is a lot easier, right? So either is fine. Right? Either is fine. So using this pointer, we are modifying the value of the member variable in a function whose only job is to display, not modify. So it's entirely possible. So for this reason, there is a safety mechanism that is often used, and that's right, writing a const after the parameter list. So if the function name, within the function you don't want anything to be modified, meaning the values of the member variables to be changed, make it essentially a read-only function, so you can write const after the parameter list. This makes this function a const in the sense that it will not allow anything to be changed within the function. Now if we run this program one more time, so we have an error here. So say this is read only, right? So you can't modify it, right? So if we comment this out, remove this basically, run it again, and now we see the name that we're supposed to see, okay, which is Robert. So this pointer is a special pointer. It always holds the address of the object that made the call to an instance function. Right? So this only works with instance function. It will not work with a static function later on, as we will see. So using this pointer, it is entirely possible to find the address. So here we are just looking at the address, right, of the object. But by dereferencing this pointer, like we did here, we dereference this pointer, meaning we dereference this pointer, which is giving us access to the object itself, to which the address is pointing to. Okay, so when you dereference a pointer, you get address to the actual, the actual variable or the actual object in this case. And when we dereference this pointer, we get to, using the SPO or the star dot notation, we can modify the name member variable, or even the GPA. You can even set the value of GPA, and it will basically change the value of GPA to whatever you want to set. So in order to prevent that from happening, we often, as a habit, put this const after the parameter list of the get function. What this means is now this get function will not allow any mutator operations or mutation operations to take place, meaning you won't be able to use this function to change anything. Okay, so a brief introduction to the this pointer and how using a const after the parameter list allows you to prevent a function from using the this pointer to modify the values of the member variable.